Hi everyone, welcome back to another tutorial session in bioinformatics. In today's video, you will learn how to assemble, annotate, and visualize a viral genome. So what we are going to do is to download an example data. We will use Spades and reads, by the way. And then we are going to assemble the reads, visualize the assembly, annotate the context that we will generate, and then visualize the annotation. So these are the activities we are going to perform. Now this tutorial was made using this online tutorial. This is the page, and I'll leave the link to this page in the description box. So we are basically going to follow what has been given here. That's what we are going to do. I will leave the link to this page in the description box. In order for you to follow this tutorial, you need to make sure you have a Unix operating system, i.e. macOS or Linux. And you should also have Mamba installed on that PC. I have tutorials that show how to install and set up Mamba, so check the description box. You'll find the links to those videos. Now that we are done with the introduction, let's open the terminal and then start the exercise. Okay, we are on the terminal now, so we are going to first install our tools. So what we are going to do first is to add channels. Okay, we are going to add 2 channels. So I'll start by saying under config add channels, and I'll add the first channel, which is the default channel. Let's add a second one. I'll say conda config add channels. The second one is bioconda. Now let's list the channels we have added. So I'll say conda config show channels. So this will list the channels for us. So we will see bioconda, defaults, and then conda forge. If you don't see conda forge, use this command here, then change this name to conda forge. So this will allow you to add the conda forge channel. Perfect. Now let's continue. What we are going to do next is to create an environment and install our tools. So I'll say mamba create -n, and I'll say assembly. This will be our environment, the name of our environment. I repeat, the assembly here is the name of our environment. Now let's add the tools. So I'll say SRATools. This will be used to download the example data. And then we have Spades. This will be used for the assembly. And then we have bandage. This will be used to visualize the assembly. And we have prokka for genome annotation. And then, so let's execute this command to install the tools. Now let's type Y to confirm. So once we do that, Mamba will download all the necessary packages, install, and configure them for us. So let's wait for Mamba to complete its work. Okay, the tools have been installed. So to use the tools, we will need to activate the environment using this command. And if we finish, we can deactivate the environment using this command. Now let's continue. We are now going to activate the environment. So we say Mamba activate assembly. That is done. So we are now going to create a working environment and cd into it. So I'll say make the assembly, and I'll say cd assembly. That is also done. What we are going to do next is to download the example data. Now let's go back to the original tutorial page. So on the page, just scroll down to this section, grabbing some sequencing data. So here you'll find the data. So we have the link, which is this one. The data is available on the SRA database. So we can search using this accession ID. We can also go to that page. Let's go to that page here. So you click on this and it will send you to that page, which is here. Okay, so when you are here, you can just check and then just get some information. So let's just look at the data, okay, the layouts. So we know from this section that the data is pendant. That is what has been given here, and it's also Illumina. Okay, we have the WGS, that strategy. We also have Vara Harene. So we have this information. So if you have some data you want to analyze, it's important you check some of this information, because that will help you to determine, or that will help you to get the right tools for analysis. That will also help you to design the analysis workflow. So we need to always check for these things. Now let's get back to our terminal. We can download using this particular section here, but we are going to do everything on the terminal. Okay, so what we need is our session ID, which is available here. So just go to the grabbing some sequencing data, and then you find the session number here. This is what we are going to use. So just make sure you also have it. I'll copy mine. So make sure you also copy yours. Okay, so that's what we have. So let's get back to the terminal and then download. We'll use the SRAToolkit. Okay, so on the terminal, we are going to call FASTQ-DAM to download. So we say FASTQ-DAM, and we say -- split files, and then we indicate the session ID, which is here. So let's execute this command. So now FASTQ-DAM will download the data for us. This will take about 3 to 5 minutes. So let's wait for the reads to get downloaded for us. Okay, the data has been downloaded. So let's do an ls, and we are going to find the files there. So these are the files. We are dealing with paired and reads. So we have our forward and reverse. Okay. Now what we are going to do next is to put these files into another directory. So we'll create another directory called FASTQ. So we say make the FASTQ, and we will move the files there. It's just a way to organize our files. So I'll say mv star.fastq, and I'll move to the FASTQ directory. So now if I do an ls, I'll have my FASTQ directory, ls into it, and we are going to see our FASTQ files. So that's what we have. So now we are going to perform the genome assembly using Spades. So we will use these files. Okay, these are the parent reads. Ideally, we should have performed the quality control. Let's go back to the original tutorial page. So we should have performed the quality control to assess the quality of the data. Okay, but for this tutorial, I'll skip it, because the purpose of this tutorial is to show you how to perform the genome assembly, how to annotate the contigs, and how to visualize the annotation. So I'll skip the quality control part. But if you have your data that you want to analyze, it's important that you perform quality control. So make sure you always do that. Okay, but there's a section here that also shows some quality control stuff. So you can read this section also, in case you're a beginner to the quality control aspect of the bioinformatics data analysis. So just make sure to check it. Okay, now let's get back to our terminal. We will perform genome assembly using Spades. So here they use Galaxy, but I am using the command line. So I'll make sure to indicate the option that were stated here. Some of the options are the default settings for Spades, so we will skip it. Those that are not, we will set it on the terminal. Now let's go back to the terminal. Okay, so we will proceed. We will perform our genome assembly. So we will call Spades. Okay, so to use Spades to assemble the reads, we will say spades.py, and we say -- careful. And I'll say -1 to specify the forward. That will be FASTQ / and I indicate the name. -2 will be for the reverse. So FASTQ, and I specify the 2. Okay, that's how it's going to be. Now let's indicate the number of threads. So we will say dash dash threads, and we will indicate 4. Now let's also indicate the output directory. So that will be -o. Now say spades underscore out. So this is going to be our final command. Okay, that's how it's going to be. Okay, so we have spades.py careful -1 for forward, -2 for reverse, number of threads, -o for the output directory. Now with the number of threads, you can increase it. Okay, so if you're using a high-end PC or if you're using a Linux cluster which has lots of cores, then you can increase this number to 10, 20, 30, or whatever has been made available for you. So this will also speed up the genome assembly process. For now, I'm using my normal laptop. That is why I'm using 4. Okay, so just make sure to use an appropriate number. So now let's execute this command. Okay, now Spades is doing its work, so let's wait for the assembly to get completed. Okay, Spades has completed its work. So if everything is successful, then you are going to see this text here, and you're also going to see this. If there are warnings, they will be indicated, so you will see them also here. Now let's take a look at one of the warnings, like this one for example. It says your data seems to have high uniform coverage depth. It is strongly recommended to use the isolate option. Now if you see something like this, I recommend that you rerun Spades, and this time factor in the option that has been recommended to you, or the options that have been recommended to you. Okay, and then you can compare the assemblies, the earlier one and the one which factored in the recommended options. Okay, there are tools that can be used to evaluate genome assemblies. One such tool is Quast, so you can use that to compare both assemblies and then choose the one which is of higher quality. Okay, so that's what I recommend you do. But for this tutorial, we are going to use what we have. Okay, we are not going to rerun Spades. Okay, but if you have your data set, it's recommended that you take into consideration whatever Spades gives you or whatever Spades recommends for you to use. Okay, now let's continue. So let's take a look at our output first. So let's do an ls, and we are going to see a directory called spades underscore out. This has our file, so let's ls into it, and we are going to find our files here. Now, each of these files, there's a description for it. Okay, so a description of each of these files can be found on the Spades website. Let's check that page out. So this is the page. I will leave the link to this page in the description box. So when you are here, just look at the Spades outputs. Okay, this section here. So click it and you'll be sent to the section which has the descriptions. Okay, so you can just read about each of the output files here. Okay, there's also a GitHub page for Spades, which is here. I'll leave the link to this page also in the description. So you can also come here to read more about Spades. Okay, so that's about this. So let's go back to our terminal. Okay, so we are back to the terminal. So in this tutorial, we are going to use the scaffold.fasta, and we're also going to use the assembly graph, which is this one here, the assembly underscore graph.fastgen. These are the files we are going to use. So we are going to visualize the assembly using this file, and then for the annotation, we are going to use the scaffold.fasta. Okay, these are the things we are going to do. Now, before we even proceed, let's explore the scaffold.fasta. Okay, let's check what we have. These are sequences which we refer to as contigs. So we can take a look at how many contigs have been identified or have been constructed. So we can use the grep command to do that. So we can say grep, and then we specify the file. So we say spades out /scaffolds.first_a. So once we do that, we are going to find the contigs. So here we have 2 contigs, okay, and that's 2 sequences. So these are the ones we have. Okay, we are dealing with a viral genome, so that's what we have. So once we have this, then we can probe further, and this is where the visualization comes in. Okay, so what we are going to do next is to visualize the assembly graph, and then we can have a discussion on it. So let's continue. So to visualize a genome assembly graph, you will need the tool bandage. Okay, so in this tutorial, what we are going to do is to visualize the genome assembly using the tool bandage. So we will call bandage, and then we will specify our assembly graph. So let's do that. So let's call bandage. So we say bandage. So let's open it now. Okay, bandage has been opened. Now it's blank because we've not loaded any assembly graph. So let's load our assembly graph. So to load the assembly graph into bandage, we go to File and we go to Load Graph. So click the Load Graph and then search for the assembly graph. So mine is found in the Spades _out directory. So I'll go into this directory and then I'll select the assembly graph. We are using assembly _graph.first_gen. This is it. So I'll click it and then I'll open here. Alternatively, you can double click. That will also open it for you. Okay, so once that is done, you have some information here telling you the number of nodes and edges and then total length. So what we will do next is to draw the graph. So come to this side, this button here, and then click on Draw Graph. Okay, so that's what we have. So if you want a different color, you can just click on the Draw Graph again, and you get a different color, and then you can also get different arrangements. Okay, so you decide the one that you want. Okay, so this is how we do it. Now let's continue. So let's just look at our graph. Okay, so here we see 2 contigs which are along this and then this. These are 2 contigs which are long. So these contigs are likely to be, let me just come here and zoom out a bit. So these 2 contigs are likely to be the ones we saw here. These contigs, these are the ones, okay, they are likely to be those ones. Now the other sequences, which are these ones, these are very short. Okay, they are short sequences, or we can also say they are short contigs. Okay, so one possible reason for short sequences appearing here, it could be due to the fact that these are repeat sequences. Okay, they are repeated sequences in the data, and so that is why they appear as short sequences. Okay, so I got this explanation from the bandage tutorial that I checked. Okay, the original tutorial, the one made by the developer himself. So he explained that one possible reason for short contigs, which are nodes. Okay, these are nodes. Okay, so one possible reason for short nodes like this is probably due to the sequences being repeats. Okay, so they are repeated sequences. That is why we have that here. Okay, so that's how we do it. Now with the assembly, you can also annotate. You can add length. That will give you the length for each of the nodes. You can also add coverage, which here is giving us depth, and then name as well. You can also customize the labels, by the way, and you can also explore each of these nodes further. Okay, so you can click, you can move them about. I mean, it depends on what you want at the end of the day. And you can also copy and blast. So for example, if let's say you want to look at this context, let's just remove the labels. Let's just say you want to look at this one, for example. We can blast it. Of course, you can do the blast in bandage, or you can just copy the sequence and blast on the NCBI database. So we can do this. Okay, So that's something that I'll cover in detail in the rest, but for now we just want to visualize the assemblies that we have. So that's what we've done. So we have our two contigs, which are this and then this, and we also have these ones, these two, which are likely to be repeated sequences. Okay, so that's what we have. So now let's go back to our terminal and then continue with the rest of the activity. So let's exit bandage. Okay, we are back to the terminal. Let's clear the screen and continue. Now let's take a look at the next activity. Let's go back to the tutorial. So we have that here. So after analyzing the results of our assembly, we have to do align the two viruses. So this section, I'm going to skip it because I'll make a detailed tutorial on that. And so I'll move straight to the annotation parts. So here we are going to annotate our sequence. Okay. By the way, I've already covered some tutorials on annotation. So if you are looking for detailed explanation of the annotation process, I've covered some tutorials on that. I've done a tutorial on how to use prokka. I've also done a tutorial on how to use bgap. So you can check the discussion box for those tutorials. So for this tutorial, we are going to use prokka to do the annotation. Okay, so let's get back to our terminal. Okay, so let's ls into our assembly directory. So ls space underscore out to find our path. So we are going to annotate the data. So we will use the scaffold.first_a. This is what we are going to use. Okay, so let's continue. So we will need to use prokka to do this. We have already installed prokka. So that is how we are going to do the annotation. So to annotate with prokka, we will say prokka. And by the way, before I proceed, let me say that this is a viral genome. Okay, so with prokka, let's just type prokka first. So for prokka, it allows you to annotate sequences of certain organisms. Okay, so we have the organisms here, the groups. Okay, so you can use these options. This one, archaea, bacteria, mitochondria, and viruses. The default is bacteria. So that means that we are going to have to specify that our data is coming from a virus isolate. Okay, so that's what we are going to do next. So let's continue. So let's ls into our assembly directory again. And then let me go over. So we are going to use the scaffold.first_a. And so we will call prokka, and then we are going to use prokka to annotate. So we will say prokka. And after that, we will need to specify some options here. So the first one is going to be the kingdom. We are going to use viruses. And then we are also going to indicate CPUs. We will use 4. Okay, so with the CPUs, if you have a high-end PC or you're using a Linux cluster, a remote one, you can increase the CPUs here so that the annotation process becomes faster. Okay, now let's add prefix. And we say SRR11528307 underscore prokka. Okay, so what this means is that all the output files that will be generated will have this name. Okay, this is going to be the base name in addition to their respective file extensions. Let's just confirm the ID. Let me just make sure I'm dealing with the ID. So I'll just confirm online just to make sure I have the right ID. Okay, so that's it. So we have SRR11528307. Let's just check. I think that's what we have. Let me just make sure. So that's okay. So that's fine. And by the way, you can also use your own name. Okay, so if this name is long, you can choose to use a shorter name, but just make sure that it's a unique name. That's it. Okay, so what will happen is that prokka will create a directory, and in that directory, all the output files will be stored. So that directory will also be called by this name, or will be given this name. Let me just put it down. Okay, now let's continue. Now let's also add another label, locus tag. This one, if you don't add it, prokka will automatically give one for you, but I just thought I would just add that. So I'll use the same name here. And then let's also specify another thing. So now we are going to specify the first A file that we are going to use as the input. That's this one here. So we will say spades out / scaffolds dot first A. That's what you have. Let's just review them again. Let me change the font size so that we can get everything on a single line. Let me try this first. Okay, so this becomes our final output. Okay, so we have prokka, we have the kingdom, viruses, CPUs for prefix, we give this, locus tag, we give this, and then we also indicate this one here. There are other options you can add. Okay, so it depends on what you want at the end of the day, but today I'm just keeping it simple. So you can check the prokka documentation, and that will give you more info. Okay, so that's depending on what you want, you can use the appropriate options to annotate your genomes. Okay, so this is just an intro, by the way. Okay, perfect. So now that we are done, let's execute this command to annotate our data. Okay, prokka has completed its work. So let's take a look at the outputs. So let's do an ls, and we are going to find a directory here. Okay, this is the name I give it. So let's ls into it. We are going to find our files here. Okay, so a detailed explanation of all these files, or let me just say a description of each of these files can be found on the prokka page. Let's take a look at them first. So on the prokka GitHub page, just scroll down. There's a section for file outputs. Yeah, that is here. So we have the descriptions here, and you can take a look at them. So we have GFF, GBK, that's GenBank, and all those stuffs. Okay, so we'll just take a look at some of them. I repeat, so we are going to take a look at some of them. Okay, so let's go back to our terminal. We'll take a look at the CSV because that can give us a summary. And so because it's a viral genome, we can quickly look at the entries, okay, because we are going to get a smaller number of annotations. So let's say, so we can do a cut, and we specify CSV, and that will give us something like this. Okay, you can also open this using a spreadsheet software. Let me even show you that also. So this is the directory, so you can open it, and then you can open the CSV, which is this one here. Okay, so we have our annotation here. So this is what we have. So it's a tab separated file. So we have them here. So we have the locus tag, we have the CDS, that's the type. So that means all these are CDS. Of course, we are dealing with an RNA virus. We also have the length, and we also have the gene. Okay, These are the genes, and we also have some information, and we also have the products. Okay, we have them here. So here we can see the names, and we also see that there are two hypothetical proteins. We see them also here. Hypothetical proteins are those proteins whose sequences have been predicted, but there is no evidence for their function. Okay, that's the simple explanation I can give for that. So this is what we have. Now let's do something else. Since we are working on a Linux system, it would be good to also learn how to explore some of these files on a Linux environment. So I'll issue some few commands that we can use to display this content. So let's get back to the terminal. Of course, we've used the cats, but then on a Linux system, sometimes you may want to display certain columns. Okay, like we have this data, for example, maybe you want to display this column, or you want to display this column, or this column, or this column. It's possible to do that. So let's take a look at them first. So that's what we are going to do. We are going to display the products. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 columns. So I'll show you 2 approaches to display them. Let's start with the first one, which is the cat command. So the cat command, and say cat -f, because it's a tab separated value, I can just use the cat command straight away without specifying a delimiter. So cat -f, and then I say 7. 1, 2, 3, 4, 5, 6, 7. So that's the 7th column. And I specify the file. So this will list everything for us. Okay, this is how we do it. You can also use that to search, but anyway, I'm going to give a detailed tutorial on how to explore files on a Linux system. So that's what you need to know. Okay, perfect. So that's what we have. So the second approach is to use the awk command. Let me show you that one also. With the awk, we say awk awk, and then we say -f, and then we indicate the delimiter, which is tab. So we bring our quotes and say /t. And then space, we bring a quote, we bring a print. A curly brackets, we open it first and we say print $7. That's the 7th column. We close it, we bring a quote, and we specify the file. So this is a tsv file. So let's execute this command. Perfect. So this will also give us that column. Okay, just as we use the cat command to do. Perfect. So that's what we have. So let's continue. Let's ls again into our annotation directory. So we have these files. Okay, you can also explore these ones as well. Okay, so there's the fna, we have fa, we have fsa, etc. Okay, but anyway, just check my tutorial on prokka and you'll find how to explore these files. Okay, so for this tutorial, I will skip the exploration of all of these files with the exception of 2 of them. Perfect. So let's look at what we are supposed to do next. So on the tutorial page, after genome annotation, we are supposed to visualize. Okay, we are supposed to visualize the annotation using jbrowse that has been given here. Okay, so that's what we are going to do. We are going to visualize our annotation using the tool called jbrowse. So let's continue. So with the jbrowse, you can check my tutorial on how to set it up. Okay, you can also follow me now as I'm going to show you how to quickly set it up before we use that. So this is the page for jbrowse. So we are basically going to download and then use that to visualize our annotation. So because I'm using a Linux system, I'll visit this page first and then get to the download page. And by the way, I'll leave the link to this page in the description box. So we need to download jbrowse first and set it up quickly. So just come to this side here. After visiting the home page, come to the download, click it, and you'll be sent to another page. So here you can download the one for your platform. I'm using a Linux system, so I'll go for this particular one here. This is what I'll go for. So to download, I'll just right click and get the link like this, and then I'll go and then download on the terminal. Okay, you can also click to download. That's also fine. So let's go to the terminal and then set it up first. So I'll say wget, and then I'll paste it there. This is the file. And then I'll download it. Okay, the file has been downloaded. Let's check it out. So let's do an ls. We are going to find it there. Okay, so I'm going to do this. I'm going to rename this file. Okay, and the name is long, so I'll just rename. So I'll say mv jbrowse, and then I'll say jbrowse. I'm going to rename it, and then I'm going to add execution rights. Okay, so if I do an ls, the file would have been renamed. So I'll just say chmod +x jbrowse. Perfect. So we have that done. Let me display the content again here. So I'll say ls prokka. So we are going to visualize. So we will visualize by feeding jbrowse with this file and then the gff file. Okay, so these are the sequences that were annotated. Okay, so we have the sequences and then the features are here. So we just load jbrowse and then load this there. We will open jbrowse and then load these files into it and then look at the annotations. It's going to be very cool, so stay tuned. Perfect. So now that we have everything we need, let's open jbrowse. Okay, so to open jbrowse, I'll say /jbrowse, and then I'll execute the command. Okay, jbrowse has been opened. Let's enlarge it. Okay, nice. Now what we are going to do is to load our files. Okay, we are going to load the fna file and then the gff file. Okay, both files were generated by prokka. So to load files or to open sequence files, come to the left side here, and then you see this button, open sequence file. So click it, and then you'll be given this window. So here you have to give a name, assembly name. Okay, so just try and then give a name. I will use the accession ID for our data. Let me just check here. It's somewhere here. I'll just copy and then paste that. Let's check. Yeah, there's it. So I'll just copy and paste. Or you can give it any name that you want. That's also fine. So this is it. Okay. We also have assembly display name. This is optional, so I will leave it. Now when we come here, we are going to load the FASTA file first. Okay, so ours is not indexed. So we will click this and then select FASTA adapter. And then when we come here, we will make sure we click on file. And then we'll click on this button here, choose file. So click this one, the choose file button, click it. And then search for the FASTA file. So the file we are going to open is in the annotation directory, this one here. Okay, the directory generated by prokka. So click it and then open it, and then search for the .fna file, this one here. So you can click and open, or you can double click. Any of them should be fine. So that will open the file for us. So once you do that, you come to submit. Okay, and then click it. And then you'll be given this window. So when you are here, make sure the option selected here is linear genome view. There are other options, but choose the linear genome view. That's what we are going to use. And then click on launch view. Click on launch view. And then you will be given this window. So when you are here, click on open. And then you have this. Okay. So at the moment, we have not loaded any tracks. Okay, no tracks are active. And so what we are going to do is to click on the open track selector, this one here. So click it, and then you'll be shown this window. Okay, so what we are going to do is to select the tracks that we want to display. At the moment, we have loaded the first A file, that sequence. So we can click it, okay, by selecting. So we just check it. That's what we have to do. So click to select it, and then the name will appear on the left side here. Okay, that's what we have. So you can just drag it left and right, but we are not done. We only loaded the first A file. We need to also add annotation. What we loaded is just the sequence. We need to add the features. Okay, we need to add the features. So on this same window, this side here, come to the bottom, the lower part, and you will see this plus button here. So click it, and then select add track. And once you do that, you will have this coming up. So make sure you click on file first, because we are going to load a file, and then click on choose file. We are using the main file here, so click on file and then click on choose file, the button here, and then select your GFF file, which is this one here, the .gff, this one. So open it and then go to next. So when you click on next, you have this. So here you leave everything as it is and then scroll down, and then you will see this. Okay, so this one, we will leave them as it is. Okay, so just click on add. And once you click on add, you will find this appearing. Okay, you find this appearing. Now let's minimize this one here. We can even close it, that's fine. So just click on the close them. We can always open them back, it's fine. So once you do that, you have your annotation. Okay, so you can drag left and right and then check what you have. Okay, that's what we have. So this one, you will see that the names are covering some parts, so you can just drag to the right a bit to see everything here. Okay, and you also check this one here. So what we have here is what's node 1. You can also see it here. So the node 1, that's the contig, by the way. You know, remember when we check the number of contigs in the assembly file, the scaffolds.c, we got 2 sequences. So it's in the node 1 that has been annotated. That's what we see here. Okay, so that's what we have. So let's also go back to the original tutorial. There are some statements there which I think you should also look at. So let's get back and then scroll down to the visualization parts. That is this one here. So when you are here, it makes this statement. It says all the arrows point in the same direction to indicate that the genes are all found on the same strand of the genome. This makes sense because we are dealing with a SARS-CoV-2 data, and this is an RNA virus, meaning that its genome sequence has only one strand. Okay, so it also tells us that it would have been a bad sign if some of the genes were pointing in the opposite direction, but so far everything we have points to the same direction, which is good. Let's just confirm. Let's get back to our window. So you can check the arrows. So this is one, this is one. You also see one here. So we see all of them are pointing to the same direction. So that is what that statement was referring to. Okay, so because we are dealing with an RNA virus which is single-stranded, that is why we should see that all the arrows are pointing to the same direction. So what we have here is good. The tutorial also makes another statement which we should check. Let's go back here. It also says that you can click on the genes to obtain information about the lengths and what database they were found to be similar to. Okay, so for example, if we click on the first protein, the name has been given here, you will find that it was found to be similar to the protein with UniProt ID this. Okay, so this means that, let's get back and check first. So that's what we have here. So it's, when we click it, we are going to find this coming up, and then you can check the statement here. So we have the name, length, type CDS, etc. But this is what the tutorial is referring to. It says it's similar to AA sequence, UniProt, KB, this one, so, and we have the ID here. So once you see this, you can look up that protein and find out more information about that. Okay, because the ID has been given here, or the accession number. Okay, so the tutorial page gives us the link, and so you can just click it to open it. I think I have it open here, by the way. Yeah, so you can click to open it, and there's a page. So when we are here, you can read more about that particular protein. Okay, that's what this statement is telling us. Okay, so once you have that information, it makes things easier for you, because at the end of the day, you are annotating. So you also need to find out more about the proteins. Okay, maybe you have some proteins you are interested in. So once you have those statements coming up, then it's important you look them up. And that is what we have just done here. Okay, so this is what we have. So in a nutshell, there are tools that can help you to assemble viral genomes and also annotate them. And this is what we have done in this tutorial. Now, in this tutorial, there are two things we did not do. Okay, one of them was quality control. Okay, ideally, when you have your FASTQ files, you should assess the quality. Okay, you should identify, you should check if some reads are of good quality or not. Okay, and those that are of low quality or poor quality, you also need to make sure you have removed them, because these things can affect the assembly process. So this is something you always have to do if you are using your own data for analysis. So it's important to, of course, and tutorials and quality control. So just check the description box, you'll find links to those videos. And also, if you're dealing with viral isolates, okay, and let's say these were taken from patients or maybe any other host, then it's important you remove the host reads from the data before you analyze. Okay, this is something that I'm going to cover in another tutorial, where I show how to remove host reads from a FASTQ file, which has been obtained from viral samples. Okay, that's something I'm also going to cover. So again, do QC and make sure you remove host reads from the data before you start the analysis. It's very, very important. So now, if you're interested in more genome assembly and annotation tutorials, then I will encourage you to check the videos in these playlists.